Gentlemen, on this episode of Friday Night Lights, we add the BMW safety box to our EV DIY fuse block. This is the BMW safety box, and it is really a contactor box. Saying safety box is branding. It's like saying ping pong versus table tennis, or a tissue versus a Kleenex. You get the idea. Before adding this safety box to our fuse block, I want to go once more over what's inside it. I think we'll enjoy a nice little demonstration and taking a look at the anatomy of a safety box. So what will we find inside there? So the stars of our show are two contactors. These are identical, but they are referred to as either a negative contactor and a positive contactor, or a negative contactor and a main contactor. Contactors are nothing more than relays on steroids. You have more than likely seen your share of typical 4-pin, maybe even 5-pin automotive relays. These days they come in all sizes, shapes, and colors. So contactors are like the T-Rexes of relays, okay? They can handle higher voltage, they can handle higher current, and they are less likely to weld shut as they open and close to let the current through. In addition to the contactors, we will find a big ass fuse. This one here is 350 amps. We need some way to connect all these components, and that's where we get these bus bars. Bus bars are nothing more than metal bars. These look silverish, but I'm thinking maybe this is some sort of a coated copper bus bars, maybe. Correct me if I'm wrong. So we have contactors, a fuse, and bus bars that connects it all. In addition to that, we have something that is called the pre-charge circuit, and it's comprised of two very important things. Pre-charge circuit has a relay instead of a contactor, because using a contactor would be an overkill, because we're not sending that much current through this component. Still the same high voltage. So if this is out of a 350 volt battery pack, 350 volts goes through the main contactors, 350 volts still goes through the relay. And then we have a, notice that says bad, a resistor. So this white bar of soap is a resistor, and it is like a funnel to step down the amount of electricity that would flow through the circuit. So when I first started learning about the pre-charge circuit, I quickly learned two things. One, that I was absolutely horrified of the concept, and two, that it was super important. Okay, so we have the main contactors, a fuse, bus bars, a relay, and a resistor. What else would we find inside of the safety box? Well, all this would have worked just fine, but the engineers decided to add some complexity. I kid, but they added this circuit board. Look at it. It's actually a foldy kind. I'm not sure if I ever seen one that folds like this before. This is pretty impressive. It's populated on both sides, of course. And attached to it is a current shunt. Sometimes when I learn or when I'm trying to explain things, instead of explaining what something is, I'll just use word substitution. So anytime you hear me say shunt, I'm just saying sensor. It's like when we talk about resolvers on motors, electric motors. Resolvers I call sensors as well. So of course they're completely different, and a shunt is a specific type of sensor and a resolver is a specific type of sensor, but you get the idea. So we will also find a circuit board which allows us to talk CAN to this safety box, and negative bus bar, one of these, I guess I found the negative one. The negative bus bar actually somehow, I don't know exactly off the cuff how it goes, but it runs through here, and the current is sensed on the negative bus bar from the negative contactor. All right, so that is what's inside the safety box. Since we learned from comparison, I want to show you something. This here is the infamous ISA Shunt. Is a Bellenhut. I know I won't even come close in the pronunciation. Okay? This is an amazing piece of German engineering. All right? These 3 ports, I believe, can sense up to 3 different voltages. This metal bar, this is where you attach your negative lead from your battery pack, and that is your current sensor. Okay? So in the Zombie, the latest release, I think now it's 2.17a, maybe a couple releases back, we have now 3 choices for current shunts inside the Zombie. So there is the ISA, this is the godfather, the GOAT, greatest of all time. And then we have the safety box, and then we have the Volkswagen AG, Volkswagen Group type, which Jamie reverse engineered for us. So there's 3 choices. But I want to show you an alternative design for one of these that you may come across. So this one, notice, had those 3 sensors. Back in the day, when I knew even less than what I know now, if you can imagine that, I purchased a bunch of these. And I think this one, which doesn't have any of those 3 on top, either senses 1 voltage only, or it only does current. I don't even remember. I was pretty intimidated doing this, okay? If you go to the Open Inverter Wiki, you will see 2 different ways to calibrate these. We can use 2 different types of Arduino circuit boards. We can use the Uno or the Dewey. I highly recommend you go to the Dewey route, but you can calibrate these with either one and then mount these to your negative contactor. So continuing on just quickly with our comparison of things, we have a choice. So I'm going to call this our second choice, okay? The safety box really came later. It's really our second choice. Our first choice would have involved using the ISA Shunt and what I would call a DIY roll your own contactor box. So when Damien talks about the current shunt and the ISA,
what is it in brief and why do we use it? Well, in short, the ISA Shunt provides the battery monitoring functions for our VCU. What it does is it monitors current. So through these big bolt terminals, we pass our full current for our EV systems through here. It can monitor 3 voltages completely independently and fully isolated. It measures temperature, it measures amp hours, kilowatt hours, and a whole bunch of other things that are very useful for us to know. Now our shunt then transmits that back to our VCU by means of CAN bus. So this kind of heavy duty metal part basically needs to form part of the negative battery feed. So we would typically put our battery negative on here, and then connect all of our load negatives, so charger, DC-DC converter, inverter, and all that via their respective contactors back through our ISA shunt, so that it can measure the energy going in and coming out of our high voltage battery system. And it can monitor via these connectors here up to 3 voltages related to our high voltage battery. And it clocks up things like current, power, kilowatt hours, amp hours, and from that we can derive things like state of charge for our VCU. So while it is possible to run the VCU without the ISA shunt, I really strongly recommend that you get yourself one of these.
He was really talking about just kind of doing your own thing. So these are orange cables, so we could call this the main contactor, the positive contactor. And these have black leads, so we could call this one the negative contactor. So we would go out there to like eBay or AliExpress or probably a more trusted site and buy some quality contactors. I'm not saying these are it. These are just as a demo here. And we would have our ISA shunt, and we would roll our own pre-charge circuit ourselves using a relay and our own resistor of sorts. Okay, I'm just borrowing these to show you, but we could have this type of DIY solution, or a couple years later came the safety box solution, and then just recently came the Volkswagen safety box. So, and I don't even know if they call it the safety box, because again, the safety box is a BMW term. So this is all part of a contactor box, and you would go to like maybe Home Depot and buy yourself a plastic box and shove these components in it. Maybe you buy something nicer that's water resistant online that doesn't conduct electricity, obviously, and that's where this stuff would live. But this right here wouldn't have CAN. This, what we roll ourselves, would not have CAN bus, because CAN bus, you know, runs on this circuit board. This is, I think this is a microcontroller of sorts. So how would we control these contactors, all right? And how does the safety box control these contactors? How does it work? We'll go over that next. So let's go over how a contactor works. And here I just grabbed one of the two. They're both identical, same part numbers. It doesn't matter if we're calling them the negative contactor, positive contactor, or the main contactor. What we're going to use, just to show that something is happening, is we're going to use a incandescent light bulb. I love incandescent light bulbs for testing because they're very forgiving. So this thing here is 300 watts, and this is a 300 watt power supply. However, this is 120 volts and this is only 60 volts. So for testing, we're going to go back to using alligator clips. And the first thing I want to do is just simply test our equipment. So we're going to put this guy aside for a minute. And I'm going to turn this on. And I've preset it to 60 volts, so the max. This is 120 volts. But will it light up with only 60 volts? I mean, doesn't this need 120? So we crank this all the way up. I feel like Scotty on Star Wars giving her all she's got. I mean, don't you guys love that movie, Spaceballs? So we're just going to simply make these connections, and this looks like spaghetti, but it's really just red to red and black to black. Okay. So I was about to say simple and it's got stuck. Okay. So let's turn it on and see if the light bulb comes on just as a test. Hey, check it out. Okay, so A bench power supply of only 60 volts can power up the incandescent light. Now it's not fully glowing, but the incandescent light says like, I'll do the best I can. So I love that about these light bulbs. Something I want to mention here is that whenever you bust out a setup like this in the EV context, people think that you're using this as a poor man's pre-charge circuit. And a lot of people do that for testing. So if you put a light bulb in series from your high voltage pack and you can test with that, I wouldn't, you probably could connect it to some higher voltage, but I would use it on like a 60 volt module with this. Maybe if you have two 60 volt battery modules in parallel for 120 volts, you could still send it through this bulb just to kind of throttle the electricity that will go into inverter capacitor to pre-charge it. So we are not using it as a pre-charge circuit. This is just a load. This could be a fan, a heater, anything. But a light bulb, I mean, it's interesting. It's catchy. We can see it, right? And it's 300 watts. So I wanted something that has some sort of a power consumption potential. Okay, so this is kind of the baseline. Now what? Well, now what we do is first we're going to leave the negative lead alone, and then we're going to take the positive the positive lead, and all we're going to do is I'm going to add some screws in here, and the only reason I'm adding screws is just to give us some sort of a studability to clip on, okay? So this is the only reason I'm putting some screws here. This is where the bus bars would connect. So I'm not sure if they need to be screwed in all the way, if they'll make decent contact. I'm gonna screw them in and see if I can still connect to them. Maybe I still can. Whoa. Oh, cool. All right. So there is our contactor with our positive lead here. Let's turn on our bench power supply and see what happens. Well, shit, that's not supposed to happen. Guys, I am being honest with you here, and nothing is staged. That was not supposed to happen, but it's such a good learning experience and a great way for me to cover up not being prepared at all. So while I prep our second contactor and pretend this didn't happen, why do you think that light bulb went on? I mean, is it supposed to? And if not, why did it go on? Contactor demo take 2. So a contactor in series with the light bulb in its path. It's like a bunch of children holding hands. Let's turn on our bench power supply. This is what I want to show you. This is uneventful. That did something that wasn't supposed to. What is happening? What is going on? Well, a contactor is just a switch. So right now, this switch is off. It's opened, if you will. We need to close this contactor. So how do we do that? Looks frantically for something he just had a second ago. Okay, so we only did half the wiring on this contactor. In addition to the main lead that this contactor opens and closes, it actually has a second connection. All right, this is what it's sort of control. It's what I would call a control. So it's just two wires. We plug it in, snap it in there, and how do we control this? Well, let's turn the main power back on. The light bulb doesn't go on because the switch in there, it's open. It needs to close. That's my switch sign. We are going to try to control that high voltage, high current contactor simply with a 9-volt battery. See if we can do this, or if I will look completely foolish. So if this battery isn't dead, I forgot to touch it to my tongue. When I connect it, so I'm pretending to be a little switch here, or a circuit board. Pretend I'm Mr. Can. I'm Mr. CAN bus. Look at that. Low voltage, low current controls this contactor. It closes it. Once it's closed, it allows the high voltage, high current to flow through the contactor, and we disconnect. So we are literally, I'm the control. I'm CAN bus. Okay? I'm a 2-wire twisted pair right now. And so when we roll our own, when I was giving you an example of this jazz, all we needed really to drive an electric car would have been 1 or 2 9-volt batteries to close these contactors. I mean, it'll be a short drive most likely, but you know what I'm saying. Just car battery to these 2 leads to close the contactor, send the current through. No CAN bus needed. No circuit board needed. Okay, you just need to close those contactors. And actually, we could do a scenario with our fuse block where as soon as we turn the key to the ignition on position, we just send 12 volts instead of 9 volts, 12 volts to these wires, just through a fuse, no relay needed because this is our relay. We close this contactor as soon as we turn the key to the on position. We could close the negative contactor simply like that, and that's usually how it's done. If you were to do your DIY, that's exactly how you would close the negative contactor. As soon as the key goes to the on position, you would close the negative contactor. We can even go further and say we can also, that way, we could also simultaneously close the pre-charge relay and start the pre-charge as soon as the key is in the on position. We would assume we want to drive, right? I mean, why else would we be in the car, right? It's not like the old days you get in, listen to the radio. Now everybody's got an iPhone or Android. You see what I'm saying? So we could solve if we were to do a DIY. If you're watching these videos going, well, Greg, I mean, I got the zombie and you're telling me I can do so much with the zombie without buying other stuff. But then shit, I can't buy the safety box alone. And if I could, it's probably like $1,800. So it's probably cheaper I buy a battery pack for like $1,000 or $1,500. But now I'm spending $1,000 to get a safety box to play with it. Well, no, you can score these. I think I paid like $30 or $15 for one of these and $30 for both of these on eBay. Sometimes these are really quality parts that will come out from big projects that never materialized or there were extras. So you can score this stuff, or even check out like the buy and sell stuff on Inventor, right? Like see what we're sharing with each other as far as a community. But yeah, we turn the key to the on position, ignition on, and we close the negative contactor and we close the pre-charge relay and we start pre-charging the capacitor and the inverter. And so that took us from a third of the way there to 2/3 of the way there. Then it's a little bit tricky when you actually close the positive contactor because you can't close that one until the pre-charge reaches a certain voltage that you preset. If you have a 350 volt battery pack, I think you want to be as close to that as possible. I think Tom shared with us in one of my comments, sort of percentage-wise, where you want to be. So let's say up to 300 volts, 330 volts maybe. So once it reaches that, then you would close the positive contactor. I'm getting a little bit ahead, but I just wanted you to understand the big picture. But yeah, this is how we control the contactors. So I think this is absolutely great. I mean, look at that. That's all this is, guys. Don't be intimidated. There's two of these guys inside that safety box. And yes, there's all this complexity here, but the zombie takes care of that. As soon as you turn the key to the on position and then you click run, it tells CAN bus to send messages to this circuit board, this microcontroller, and it then sends a signal from this circuit board. There are actually plugs on here. So I hope you guys can see this. Maybe. I think, this will plug in here. And you can see that this plug, hopefully I'm not all over the place with my explanations. So this plug has these twisted pairs, which we think were CAN. We learned that they're CAN, but in this case, I can see the same colors. There's a blue and a gray one, matches this blue and a gray one, so that this circuit board, we know this circuit board has that blue and a gray wire that eventually ends up running to here, and that's what controls it. And there's a black and a gray one, which is probably for the other contactor, right? And then there's a red and a gray one, which I'm pretty sure ran to that pre-charge relay. So all those, that's exactly what this circuit board is doing through these three twisted pairs. It's just talking to the two contactors and the relay, and it opens and closes them. That's it. It just open them, close them, open them, close them. That's what it's doing through this circuit board and that contactor, right? Okay, so let's turn that off and let's finish our demo with a quick explanation. Why did this contactor light that up? Okay. That's bad. This is a bad contactor. I welded this thing shut. This thing is always in the on position. This is not the first one I welded. This is the first one I welded. And I carefully disassembled it for you all so you can see what's in there. So this on top is that. There's little springy thingies in there. You can see. And this is filled with some sort of a super duper gas. And then this is a magnetic, I think, coil or just magnet. I think it uses magnets or something like that to pull the thing down. I think it's like this. Oh yeah, I can even sense maybe a little bit of magnet stuff now. Yeah, I deliberately, obviously, thrashed that one. So you can see the contacts are here. I thrashed one to see what's in there because that's how I learn, because I'm a barbarian. I'm a gorilla. I'm a curious mind, but, I wasn't born with the electrical engineer gene. I think this was in there too. This was spring loaded. And this is actually what got welded. So I don't know if you can see the 2 points. That went in there like this. And that's what got stuck. So the way you fix these, and I've done it. At first I didn't think it could happen, but you do that. Trust me, man. You can get lucky. And first I was like, man, I don't know what's in there. This is expensive. So I was like, rubber mallet. Come on, baby, fix yourself. No, I was pretty upset one day because the truck was ready to go, and I welded shut one of my contactors, and I had some good friends on the Open Inverter forum telling me, man, you can kind of tap them open, trust us, you can. And so I was out in the backyard doing that until the thing got unstuck. Sometimes it works. Let's see if that worked. Nope. It's still welded. It's still welded shut. It's not supposed to come on with no voltage control here. Well, so be it. These you haven't done an EV conversion until you welded a contactor shut or fried your first or second resistor, aka bar of soap. Okay, guys, it happens. It feels like a swift kick to the groin, and it deflates you. But press on. Have this mentality of not what will I do if something happens, if something bad happens, if there's a setback. Have the mentality of how will I handle it when it happens? Because it will. This is uncharted territory. You're taking on a big task. You can do it, but don't let a setback set you back. Okay, enough rambling. Okay, I don't think there was any rants in that. Do I need to reshoot this?